Welcome to The Explainer. Today we're looking at a true David versus Goliath scenario in the world of AI. We're breaking down a fascinating research paper submitted on March 12, 2026 by Alejandro R. Salamanca and an incredible team of 25 other authors. It's called Tiny AI, Bridging Scale and Multilingual Depth. In an industry where the prevailing logic literally screams that bigger is always better, this team decided to completely flip the script. They set out to prove you absolutely do not need a monolithic, resource-heavy model to get world-class, global language capabilities. So we're going to break down exactly how they pulled this off.
Okay, let's dive into this. Think about this massive number, 70. That's the staggering number of languages this model is trained on. When we talk about global AI, historically, a lot of systems just kind of hit a brick wall after mastering a handful of high-resource languages. Think English, Spanish, or French. But Tiny AI? It's built to communicate, translate, and actually understand across 70 distinct languages. It's just a massive, sweeping scope of linguistic diversity. It essentially covers a huge portion of the globe's conversational footprint. Now, to handle that many languages effectively, you'd probably assume we're dealing with an absolute computational giant, right? Well, that leads us directly to the central paradox of this whole paper.
3.35 billion. That is the total parameter count for Tiny AI. Now, just to put that into perspective for a second, 3.35 billion parameters is astonishingly small. We're living in an era where frontier models basically require the computing equivalent of a small power plant just to run, and developers are constantly bragging about hundreds of billions or even over a trillion parameters. Yet here is Tiny AI packing 70 languages into this hyper-compact 3.35 billion parameter footprint. It's honestly like running a supercomputer on a AA battery. It's an absolute engineering marvel, and it immediately challenges our basic assumptions. I mean, how can something so relatively tiny hold so much multilingual depth without its performance just totally collapsing?
Well, that brings us right to the core problem we're looking at today, the multilingual AI challenge.
So, to solve this major issue of AI being locked behind super expensive computers that are frankly incredibly difficult to deploy in the real world, the researchers made a very bold claim. I'll read this right from their abstract. Tiny AI redefines what a small multilingual language model can achieve. I absolutely love this quote because of the sheer confidence in that word redefines. They aren't just claiming some minor incremental tweak here, they're stating that the baseline expectations for small models have officially been shattered. That huge size-to-performance barrier that has historically restricted global deployment, it's no longer the impassable wall it used to be. But hey, a bold claim needs brilliant methodology to back it up.
Now, what's really interesting about this slide is this secret sauce behind this whole capability. It's a technique called region-aware post-training. So rather than just dumping a massive pile of global data at the model and crossing their fingers, hoping it figures it out, the researchers use this highly specific refinement process. Region-aware post-training essentially means the model is deliberately optimized to balance its performance across diverse global languages. It makes sure that lower resource languages aren't just treated as an afterthought totally overshadowed by English. It grounds the AI's understanding in actual regional nuances, which makes it dramatically more efficient and culturally attuned. This is the exact technical breakthrough that makes a 3.35 billion parameter size actually work.
So let's take a look inside the model release.
When the team published this paper, they didn't just drop a single file and call it a day. The release is actually broken down into 3 distinct, highly digestible tools. First up, you have a pre-trained foundation model. That's your base layer, the raw engine. Second, there's a globally balanced instruction-tuned variant. This version is basically ready to follow your commands and act as a conversational assistant right out of the box, perfectly balanced across all 70 of those languages. And third, and this is perhaps the most innovative part, 3 region-specialized models. They realize that sometimes you just don't need the whole world. You just need deep, highly specific expertise for one certain part of the globe. And this brilliantly illustrates exactly what we're talking about. The researchers targeted 5 very specific real-world regions: Africa, South Asia, Europe, Asia-Pacific, and West Asia. By focusing explicitly on these areas, they're taking abstract AI and grounding it in actual human geography. They're actively building AI for the global majority. This ensures that regions historically underserved by the big tech releases are getting first-class, highly optimized language models that are actually small enough to deploy locally. It's a real game changer.
But obviously, none of this matters if the model doesn't actually perform, right? Well, through a really comprehensive evaluation framework detailed in the paper, Tiny AI proved its worth across 3 major performance achievements. Step 1, state-of-the-art translation quality. It seamlessly translates between these highly diverse languages. Step 2, strong multilingual understanding. So it doesn't just blindly swap words, it actually comprehends the deeper context and meaning across totally different linguistic frameworks. And step 3,
high-quality target language generation. When it speaks back to you, it does so fluently and naturally in the language you requested. Delivering all three of these at a state-of-the-art level using only 3.35 billion parameters, that is a monumental flex by this research team.
Let's move to and see how this builds into a new scaling path.
We're essentially looking at a massive crossroads for the future of AI development. On one side, you have the traditional scaling path, which is basically all about implied massive scale, massive compute, and massive resources. You know, bigger servers, way more power. But on the other side, you have Tiny AI's alternative scaling path. This approach prioritizes efficiency, perfectly balanced performance across global languages, and crucially, practical deployment. It's kind of like the difference between building a fragile luxury sports car that can only run on a millionaire's private track versus engineering a highly efficient, rugged vehicle that runs perfectly, literally anywhere in the world. And the researchers summarize this ultimate thesis perfectly right at the end of their abstract. They state that Tiny AI presents an alternative scaling path for multilingual AI, one centered on efficiency, balanced performance across languages, and practical deployment. That phrase right there, practical deployment, that's the whole anchor. Because think about it, what good is a brilliant AI if the people who actually need it the most can't even run it? By proving that this tiny, efficient model can hit state-of-the-art multilingual depth, this paper fundamentally shifts the horizon of what's possible for global developers.
Which leaves us with this final, truly vital question to ponder based on everything we've just uncovered today. What will a more accessible, globally balanced AI mean for you? When advanced, multilingual understanding no longer requires a massive supercomputer, when it can be practically deployed in South Asia, in Africa, in West Asia, seamlessly crossing 70 languages without breaking a sweat, how is that going to change the way we communicate, build, and learn? The Tiny AI paper proves that the future of AI doesn't have to be massive to be profoundly impactful. Thanks so much for joining me for this explainer, and I'll catch you next time.